Hello and welcome back. In this video, I'm going to continue with a demonstration how to create a stack using linked lists. But now I'm going to make the demonstration on a microcontroller. I'm going to use a microcontroller, a STM32 microcontroller, and I'm going to use the STM CUBEIDE, STM32CUBEIDE. Okay, I'm going to share my screen. Here you are. I'm going to share. Okay. I've created the project, and I've copy and paste my code from code blocks. Is a checked approved code, but in this case I have to make some changes, because, for example, when I want to use printf works on computer. Obviously, it's inside the compiler, it's inside the standard. But when I use printf, the statement printf on the computer knows that it has to send the data to the standard output, the screen. But in this case, I'm going to create my stack and interact with the user using a UART to send and receive characters, and using an external terminal to play with the menu and to save, to push nodes into the stack and pulls nodes from the stack. So the first thing, I have to program the pins on my microcontroller. I'm using an STM32 F411RE. Connectivity, I've set my compiler to use the UART number 1, synchronous, and I'm not going to use interruptions, not use the DMA. The only thing I'm going to configure is the baud rate. No 1600 bits per second, 8 bits, including parity, non-parity, and 1 stop bits. I changed the number of samples to 8 because it's enough to work with this speed. Okay, and I don't need any more. Those are the pins to the transmission and reception. Okay. Now I'm going to my main. The main has been created automatically using this ID. The ID sets the UART, the baud rate, and everything we need to work. And I've added the libraries I used, the stack, the UART, and the math. Those one has been created because I have to manage my UART, and this one has been created because I have to deal with the strings on the computer using the code blocks or Visual Studio Code. The computer manages the strings not automatically, but the functions are works better, or automatically adds, for example, the null terminator to the string. In this case, I need math to convert strings to integers and integers to strings. Okay, it's a library I'm going to use. The UART, and to do all those things and to get my code in order, I mean to get my code with some order. I created these folders like libraries. They are workspaces, and I've created them using project properties, general, path and symbols. And here I've added my includes, my .h files includes, and I've added the path to find the files, the header files. Okay, and here I've added my folders to locate my source code. Okay, so the program, the IDE can work with this code as it was a static library, I want to say, a static library. Okay, here in my stack, I've created well, I add my libraries to work with, and I add my code. I've demonstrated in code blocks, and I declared my push, my pull, print notes, print message, and other helping functions that I need because I'm working with a microcontroller, and I have to work with a more low level of coding. So I have to define things that the computer make automatically when work with Visual Studio or code blocks. But in this case, I have to create my own functions to make the same, or to simulate the same. And here we have our code created, print message, is a string. We can see instead use puts doesn't exist here, or instead to use printf, have to create a function to send UART. This function is going to send this string to the UART, and the UART will transmit the string to the terminal. Okay, the only one to say is I've changed some changes to implement this. Okay, and in our main, I've copy and paste my menu, but instead using printf and using send UART and a helping function I've created to do this. Well, the switch statement, the cases is the same like in code blocks, but making some arrangements. Okay, now I'm going to check if it works. Zero errors, zero warnings. Now I'm going to debug this program and see how it works running on the microcontroller. Okay. And now I've created my program in the IDE, and I'm going to upload in my microcontroller. This is my hardware that I'm using. It's an STM32 F411RE, and this is a device to communicate my UART reception and transmission. I convert these signals to an USB, and this USB is going to send my signals from the UART to a terminal to communicate my microcontroller with my screen, with my computer. Okay. Now I'm going to share my screen. Okay. Here we have our microcontroller, our hardware, and I'm going to run the program. Disconnecting. Now I'm going to open my terminal. Command 4, the speed, the bit, number of bits and parities, and the stop bit. I'm going to run my program. It's connected. Okay, here we have our menu. All this text is sent by the microcontroller. If you see the lights of transmission and reception here in this device, you can see every time the menu is printed how the lights light. Okay, the lights blink. I'm going to choose select an option. I'm going to print the nodes because the stack is empty. Now I'm going to extract the nodes because it's empty. Now I'm going to add the nodes. The first name is going to be reason 43. C to continue. There'll be one node on the stack. Okay, and now I'm going to add 2 more nodes. Maybe 48. Okay, the last one wasn't right. I mean, okay, I'm going to extract the last one. I'm going to create the last one again. 48. Okay, now I have 3 nodes on my stack, and I'm going to extract to pull the last one. It's going to be JB848. Okay, JB848, and there are only 2 nodes left. Here we are. I'm going to extract the last one. The last one now is David H35. Okay, here we are. And the last one, his name Jason H43. Going to extract the last node, and the data from the last node is extracted. Okay, no to extract, and 3, no more items on the stack. Okay, I hope this video has been useful. The final implementation from the theory, the test using an IDE, testing the theory, and finally creating the implementation inside a microcontroller, creating a menu interface to play with a microcontroller to control the stack. I hope it's useful for you, and see you in the next video. Thank you for watching.